Welcome to today's Explainer. Today, we are taking a trip into the absolute unknown. We're going to completely strip away the complex astrophysics equations and put you right in the center of the action. We're embarking on a visceral, first-person cosmic journey straight into the ultimate abyss. We are going to explore the terrifying, awe-inspiring answer to one of the wildest questions out there. What actually happens if you fall into a black hole? Okay, let's dive into this. Did you know that if you fell into a black hole, you actually wouldn't disappear right away? I mean, think about it. Most sci-fi movies make it look like a simple magic trick, right? You cross this invisible line in space, maybe there's a quick flash of light, and poof, you're gone. You'd think you just vanish instantly, erased from existence in a fraction of a second. But as we'll see today, the actual physics of our universe dictate an entirely different, much more fascinating, and honestly, significantly more terrifying reality. You definitely do not disappear right away. All right, Section 1, the journey to a black hole, a cosmic freefall. So, the crucial point here is how gravity actually works at these immense extremes. I want you to imagine yourself just traveling through the vast, freezing emptiness of space. You're cruising past distant stars, when suddenly you find yourself approaching a massive black hole. It's just sitting there like a giant cosmic vacuum cleaner. As you get closer, imagine stepping outside your ship in your spacesuit. You are now in a terrifying freefall toward a massive sphere of absolute darkness. Step 1, you're approaching the black hole, and hey, everything feels somewhat normal at first. But then comes Step 2. The gravitational pull begins to affect you unevenly. If you're falling feet first, the gravity pulling on your feet is vastly stronger than the gravity pulling on your head. And that leads to Step 3. Because of this radical difference in gravitational strength across just a few feet of your own body, you begin to experience some extreme physical elongation. Which brings us to Section 2, the process of spaghettification, a gradual transformation. And this brilliantly illustrates what scientists actually call spaghettification. Let's slow down the pacing for a second here. Just imagine the sheer tension of this moment. You are actively feeling this immense, stretching force, and it doesn't just happen in the blink of an eye. The tidal forces of the black hole are literally tearing at the molecular bonds of your spacesuit and your physical body. I know, it sounds almost silly, kind of like a joke, right? But it is an actual, legitimate scientific term. The extreme gravitational pull stretches your body slowly until it becomes incredibly long and impossibly thin, exactly like a strand of spaghetti. The gravity compresses you horizontally while ruthlessly stretching you vertically. Using this spaghetti analogy makes a terrifying and incredibly complex astrophysics concept strangely relatable, doesn't it? Let's move to Section 3 and see how this builds. The event horizon, the point of no return. So you're stretched out, you're helplessly falling, and now you're approaching the absolute climax of this cosmic journey, the boundary line, the edge of the abyss. As your elongated body continues to plummet, you reach the event horizon, the ultimate point of no return. The gravitational pull here is so unbelievably immense that the escape velocity required to leave is greater than the speed of light itself. And since absolutely nothing in the universe can travel faster than light, well, nothing escapes. Crossing this boundary means stepping into ultimate, inescapable darkness. You are entirely, permanently cut off from the rest of the observable universe. So, what actually happens to you after crossing the event horizon? You've crossed the boundary. The rest of the universe can no longer see you, and there is absolutely no turning back. You're plunging deeper and deeper into the dark. Does the stretching just continue forever until you're nothing but a single string of atoms, or do you hit a solid, unimaginably dense surface? That brings us to Section 4, the universe's greatest secret, beyond the horizon. Now, what's really interesting about this slide is how it splits the two most mind-bending possibilities. Because the incredible truth, to this day, no scientist, no supercomputer, and no theoretical physicist knows for certain what happens next. The laws of physics, exactly as we understand them today, completely break down beyond the event horizon. The math just simply stops working. So there are two main possibilities that theorists have proposed. On the left side, perhaps you reach the center, the singularity, a microscopic point of infinite density where all matter that has ever fallen in is crushed into an unimaginably small speck. It's the absolute end of the line. But on the right side, it could actually be a gateway. Some mathematical models suggest the center of a black hole might not just crush you into nothingness, but could instead act as a cosmic bridge, like a wormhole, that might spit you out into an entirely different cosmos waiting on the other side. The truth is, the universe is still hiding its biggest secrets from us. Whether this journey ends in a crushing singularity or acts as a spectacular doorway to another universe, space remains a vast, beautiful, and utterly terrifying mystery. We can map out the stars, we can measure gravitational pulls, and we can take pictures of the glowing dust swirling around them. But the true heart of a black hole, that remains the ultimate enigma. Which brings us to a really compelling final thought. Just think about the sheer scale of the unknown. If a phenomenon as massive, powerful, and central to our galaxy as a black hole remains completely unexplained at its core, what other massive secrets is the universe still hiding from us? What else is out there in the dark, just waiting to be understood? Thanks for exploring the unknown with me today. Keep asking questions and keep looking up.